Your laptop says Intel, your GPU says NVIDIA, your phone says Apple, and none of them owns the factory that built the chip inside. Today, we're peeling the label off the silicon and mapping who designs chips, who manufactures them, and why that split decides your battery life, frame rates, and upgrade FOMO. Welcome to Quantify, plain English, zero fluff. Let's go. Think of a chip like a skyscraper. The architect draws the blueprint. The construction company pours concrete and stacks steel. Then the fit-out crew wires the elevators, water, and fire alarms so people can live there without panic. In chips, those jobs are design, foundry, and packaging. 3 different specialties, often 3 different companies. Step 1, design. This is where the chip's blueprint is drawn. Engineers decide the number of CPU cores, the type of graphics engine, how fast the memory should talk to the processor, and which features matter most depending on whether the chip goes into a phone, a laptop, or a giant server. Step 2, manufacturing. The blueprint is sent to a foundry, the ultra-clean factory where transistors are etched onto silicon wafers. At this scale, even a single speck of dust can ruin the entire batch, which is why these facilities cost tens of billions to build and run. Step 3, packaging. Once the wafer is sliced into individual chips, they're connected to the outside world. Packaging links them to memory, adds cooling solutions, and sometimes even stacks multiple smaller chips and layers of ultra-fast memory together so they function as one powerful unit. Miss any one of these steps, and that cutting-edge processor you designed is nothing more than a very expensive paperweight. Meet the first group, fabless designers. They do the brains, then outsource the files to a factory. Designers. Apple. You've heard of them. They designs the A series for iPhones and the M series for Macs and iPads. Do they build them? No. TSMC in Taiwan does, using its most advanced manufacturing processes. That's how Apple launches first on new nanometer nodes. They secure priority access at TSMC. NVIDIA designs GPUs and massive AI accelerators like the H100 and Blackwell. Built by TSMC, their secret sauce is in packaging, pairing those processors with stacks of high bandwidth memory so data moves at lightning speed instead of crawling. AMD designs Ryzen CPUs for PCs, EPYC CPUs for servers, and Instinct accelerators for AI. Manufacturing? Mostly TSMC again. AMD leans heavily on chiplets, smaller dies linked together, so they can mix and match parts, improve yields, and keep heat under control. Add memory stacks and you get efficient hardware that punches way above its weight. Qualcomm designs Snapdragon chips for phones and now PCs. Some generations were built at Samsung Foundries. Today's flagships mostly rely on TSMC. Why the switch? Power efficiency, yield rates, and cost. Think of it like airlines rerouting flights depending on the winds. MediaTek designs Dimensity chips, shipping at enormous scale, almost all on TSMC. In the Android world, MediaTek is the quiet workhorse, the buffet tray that never runs empty. Google designs Tensor chips for Pixel phones. The first ones were built by Samsung, but newer ones moved to TSMC. In the data center, Google's TPUs, Tensor Processing Units, power AI training and inference, also fabbed externally. Foundries. External foundries. Some companies design the brains, but hand off the heavy lifting. Google designs Tensor and TPUs, but someone else prints the silicon and bolts on the memory fireworks. Amazon, AWS, designs Graviton CPUs and Inferentia Terranium AI chips, built at outside fabs. Most often, TSMC, because Amazon wants performance, not a billion-dollar fight with wafer physics. Microsoft Azure designs Cobalt CPUs and Maya AI accelerators, again manufactured externally with advanced packaging. The priority? More cloud capacity, not running a materials science museum. Meta designs MTIA for inference, manufactured at a foundry, deployed at massive scale, and bottlenecked by the same thing that defines AI hardware everywhere: memory bandwidth. Huawei HiSilicon designs Kirin chips for phones built by SMIC in China, which is advancing steadily but not quite catching the leaders at the cutting edge. Tesla designed the Dojo training chip and in-car compute units, fabricated externally because even with rocket company energy, fabs aren't a weekend project. The builders, Foundries. Now the actual construction crews. The companies that etch features into wafers thinner than your patience during a Windows update. TSMC, the industry giant, it manufactures for Apple, Nvidia, AMD, Qualcomm, and more. If a headline says fastest chip, the footnote usually says built at TSMC. Beyond wafers, TSMC runs elite packaging technologies, CoWoS and SOIC, that stitch multiple dies and memory stacks into one blistering fast package. Samsung Foundry, the other leader at the front, builds Samsung's own Exynos chips and has also produced parts for Qualcomm and Google. Its bet? Closing the gap with TSMC by pushing both process nodes and packaging innovation. Intel, a classic IDM, integrated device manufacturer. For decades, it designed and built its own CPUs. Now it's reinventing itself by opening factories as a contract foundry. If customers start tapping out at Intel's newest nodes, the market gets a genuine second source at the cutting edge. Global Foundries focuses on mature, stable process nodes, essential for cars, Wi-Fi, sensors, and power electronics. Less glamorous, but absolutely mission critical. SMIC, China's main path to domestic silicon. Progress is constrained, but it's climbing node by node. IDMs and specialists. Some companies still do both design and manufacturing under one roof. Intel and Samsung are the flagships here. Others specialize. IBM designs chips, while Samsung fabricates them. In the analog and power world, companies like Texas Instruments, ST Microelectronics, Infineon, and NXP dominate, building chips on mature nodes that quietly keep your car, appliances, and factories alive. No RGB lighting, just reliability at scale. Memory and packaging, the speed glue of AI. SK Hynix, Samsung, and Micron make HBM, high bandwidth memory, tower-like stacks that keep GPUs fed. Without HBM, the chip is starving no matter how smart the design. Packaging, done at foundries or by specialists like ASC and Amkor, is where chiplets, memory stacks, and I/O lanes are stitched together. In the AI boom, packaging capacity is gold, a bottleneck that can delay entire product launches. Who works with whom? Apple, TSMC. Nvidia and AMD, TSMC. Qualcomm, TSMC or Samsung. Google Tensor, Samsung, TSMC. AWS, Microsoft, Meta, TSMC. Huawei, SMIC. When a release says we made a chip, read designed by us, built by X, packaged with Y, memory by Z. Why don't most brands own a fab? 3 reasons. Cost, a leading edge plant runs $10 billion before the first wafer. Risk, getting a new node to behave is like teaching a cat to file taxes. Possible, but painful. Focus, designers pour into architecture and software. Foundries master materials, lithography, and yield. Specialization wins. What's hot now? Custom cloud silicon. Big platforms are building chips to cut power and avoid rivals. Packaging is the new horsepower. Stitching chiplets and memory towers into one module and limited packaging lines can stall an entire launch. Intel's foundry push aims to give designers a real second source at advanced nodes. Samsung is racing on process and packaging. China's ramping domestic capacity, and on PCs, ARM laptops are getting very real, while x86 still hauls the heaviest loads. If you bolt on a cooler the size of a small apartment. Quick FAQ, lightning round. Does Apple make chips? Apple designs them. TSMC builds them. Does Nvidia own a factory? No. Nvidia designs, TSMC builds. Who makes AI chips? Designers, Nvidia, AMD, Google, AWS, Microsoft, Meta. Manufacturing, often TSMC. Memory, SK, Hynix, Samsung, Micron. Who's the best foundry? For the tiniest transistors right now, TSMC. Others are racing hard. What does ARM do? ARM licenses CPU and GPU designs. It doesn't run fabs. Your favorite chips either use ARM's cores or follow ARM's instruction set. Here's your press release translator. Designed by equals the brains. Manufactured on TSMC, Samsung, Intel 345NM equals the factory and process. CoWoS, Foveros, Info, Xcube equals packaging styles that glue chip pieces and memory together so bandwidth goes brrr. If a company skips who built it and how it's packaged, that's like bragging about a sports car without mentioning the engine or the tires. When a brand says, "We made a chip," you now know the follow-ups. Who designed it, who built it, how it's packaged, and whose memory feeds it. If this cleared the fog, tap like, drop your next matchup in the comments, TSMC versus Samsung versus Intel, or the cloud giant's custom silicon, and subscribe to stay quantified. Designers sketch it, foundries print it, packagers stack it, memory fuels it, and your apps either fly or wheeze like a laptop running PowerPoint.